Understanding how working memory works in the human brain is extremely attractive and important because once we understand more and more about the working memory processing, that paves the way to a lot of other questions that we have when it comes to how the brain functions, specifically when it comes to creating memories and recollecting memories. The reason working memory is so important is that it has a very limited capacity, at least to our knowledge, for whatever reason they may be. But the way in which it appears to work is that it puts incoming information, organizes them in a hierarchical chunks. In other words, it organizes them in chunks, and as a result, when it tries to recollect that information, it remembers the hierarchical events, like remembering, for example, a series of movie episodes in hierarchical form, or if you, for example, trying to remember a phone number, we put it in different chunks, and as a result, we help the working memory address its capacity issue because those numbers are in chunks, and as a result, we remember those chunks instead of one number at a time. And this is very important for us to understand because not only is this way of dealing and processing with information is important when it comes to working memory, but also in higher cognitive functions such as language, for example, or other information processing way in which the brain collects and organizes and works with different information. Understanding the underlying neural mechanism of working memory is extremely important because it would also pave the way for us to understand the underlying neural mechanism of other cognitive function, such as language processing model, for example. And we already know that working memory has a very limited capacity. And so the question is, how does the incoming information gets organized such that it addresses the limited capacity issue in the working memory? It appears that at the underlying neural mechanism, when information comes in, immediately the brain appears to what we call factorize the information, meaning to say that it disentangles the information. In other words, it organizes the information such that it can somehow process and work with the incoming information. And this factorization appears to be sequential, hierarchical sequential, and it appears to have something to do with the content. In other words, the information that comes in, it has to do with the content in which the information comes in, and the brain miraculously starts at the underlying neural mechanism. It appears to organize and disentangle, in other words, factorize that incoming information. And so the proposal here is that the working memory contains factorized information, aka disentangled information, that represents the hierarchical order of the incoming information as well as the content of the information. And the underlying neural mechanism of this system is unknown to us. And so these researchers set out to examine the underlying neural mechanism by using methodologies such as EEG and MEG. EEG, as you already know, is the brain waves. MEG is the electromagnetical field. And so the question here is that we already appear to know, based on behavioral data collection, that there is some type of an hierarchical organization that is happening in the working memory, but the underlying neural mechanism appear to have been collected either at a one-dimensional level or two-dimensional level. So it appears that the neurological or neural mechanism of these working memory processes is more geared towards a two-dimensional geometry of neural mechanisms. In other words, this two-dimensional neural geometry of the working memory appears to factorize or disentangle incoming information to very complex, hierarchical type of information regardless of the content, and puts it into these two different axes. How exactly it does that, it is still unknown to us, but the fact that it does that has become apparent through these EEG and MEG devices, where the way in which the working memory tries to compensate for its capacity issues, it basically used two-dimensional geometry of factorizing the information into different complex levels of sequence, and the neural network underlying that process is at a two-dimensional level that, again, it can include having multiple very complex sequences just because it's no longer one-dimensional but is multi-dimensional. To sum up, these scientists were able to demonstrate that through EEG and MEG data collection, that as soon as an information comes into the working memory, the brain restructures and factorizes or disentangles that incoming information and put the representations of that information into two-dimensional neural geometry. And as a result, the working memory is able to address its limited capacity issue, because in this way, this very smart way, I should say, where the neural representation are not only one-dimensional but two-dimensional, in this way the working memory is able to include much more complex sequences and hierarchical representation of the incoming information, and as a result it's able to not only store the information in such limited capacity but also recall that information from the limited capacity of the working memory.